Hello students, we will be today learning about application of Gauss law, and for that I have drawn a small circle. Let's first talk about point lying outside the charge where small r is greater than capital R. And we see you see here I will make another circle, and on the top of that there is another circle. This is the point where charge is located plus q, and we also say it is 0. Then the distance between small this is r, then uh, this is small r with point P. Okay, so let us consider the charge Q, which is uniformly distributed over a sphere of radius r as shown in the figure. Let us again consider a point P at distance r, small r, outside the charge. Okay, charge sphere outside the charge sphere, where we have to calculate the electric field strength. Considering the Gaussian surface at this point P, where the electric field intensity is same the point on the Gaussian surface, we can write from Gauss law. You can ignore the like this. We can write like from Gauss law. From Gauss law, okay. I'm writing total flux. Total flux phi is equal to total charge Q by epsilon naught. I've already derived this equation. That is phi is equal to Q by epsilon naught. Now also also right, phi is equal to E dot A. Okay, so E dot 4 pi r square is sphere of for sphere area is 4 pi square. So now we can write, so E is equal to, sorry, E dot 4 pi r square is equal to Q by epsilon naught, which is equal to Q by 4 pi epsilon naught r square. And from here we can conclude that E is directly proportional to 1 by r square. And this is what we need. Okay, so thus the field outside the sphere is same as if all the charge were concentrated at its center. This means that for this charge, if this is the source of charge, the charge is same as here, here, and here. This is application of Gauss law. Okay, when the point is on the surface, this is second application of Gauss law. What we see is this O and this point P. Okay, and then radius r. So charge is plus q. So when the point P lies on the surface of the charge sphere, then drawing the Gaussian surface area would be equal to that of the charge sphere. That is area. Okay, area A will be equal to 4 pi r square is equal to 4 pi capital R square. Okay, then we can say phi is equal to q by 4 pi epsilon naught r square capital R square. Okay, also we can say small r square. This is simple. Then we will see third application of Gauss law, which is point lies inside the sphere. Okay, what is this? Third point lies inside the sphere when r is smaller than capital R. Okay, let us draw a sphere. This is the origin where charge is located. Then let us see a point P which is inside the charge. Okay, then the radius will be capital R. When the point P lies inside the charge sphere, forming concentric sphere of radius R with it, as the surface lies inside the sphere, the new concentric sphere does not enclose any charge. Okay, uh, so inside it, because the charge lies on the surface of the conductor, now we can say total flux phi is equal to EA, that means E into 4 pi R square. Okay, the distance between OP is R. Here, distance between the point and the charge is small r. So flux at point P will be 4 E pi R square. So from Gauss theorem, phi is equal to Q by epsilon naught. Charge will be 0 by epsilon naught will be 0. Since the charge enclosed by the Gaussian surface is 0, we already saw that when the charge is enclosed by Gaussian surface, this is Gaussian surface, this is Gaussian surface, and the charge is enclosed by Gaussian surface. So we will so flux will be 0. Okay, this is Gauss theorem. When the charge is not enclosed, okay, then only we can write flux is equal to Q by epsilon naught. When the charge is enclosed, we can when the charge is enclosed, then we can apply Gauss law. But since the charge enclosed by the Gaussian surface is 0, we cannot apply here. So charge is 0. Okay, charge enclosed by Gaussian surface is 0. Okay, that is line of force or flux, line of force or flux. We can say flux. That is we can say flux passing inside the body, passing inside the body is equal to 0. Okay, so E is equal to 0. When flux becomes 0, E becomes also 0, because E is equal to Q by 4 pi epsilon naught R square, and Q is 0, so everything is 0. Okay, charge is 0. And why charge is 0? Because it is enclosed by Gaussian surface. Okay, means within the charge surface E is equal to 0 on the surface of so when within the charge sphere, I will write here. So the conclusion we get from the three application is within the charge sphere E is equal to 0. On the charge sphere E is equal to Q by 4 pi epsilon naught capital R square. Outside the charge sphere E is equal to Q by 4 pi epsilon naught small r square. So what we did was nothing but for first on the first application of Gauss law, when electric field intensity due to solid charge sphere, point lying outside the charge, when point was lying outside the charge, what we did was from Gauss law we find out two things, like flux is equal to Q by epsilon naught. We use Gauss theorem, and also we know flux is equal to EA. Okay, and area is 4 pi R square, means E into 4 pi R square. Okay, so instead of R square, and we put this phi uh, in here. Okay, and then we mix up two equation and find out that E is equal to Q by 4 pi epsilon naught R square. Okay, we find out that in first property, this is when the charge is outside, point like P is there outside, outside the Gaussian surface or charge sphere, and we assume that the circle is the radius with P is r small r, and radius with this is capital R. So this R is distance between charge and the point. Okay, so this one was first, and I'm doing summary, and the second one was when the point was on the surface. Here we directly write like phi is equal to Q by 4 pi epsilon naught R square, is the point now is here. Okay, the point now in the second quest, point now is here, so small r is equal to capital R, so we can write phi is equal to Q by 4 pi epsilon naught R square from this. Okay, we can write this. And for third point, okay, uh, in third point the point P was inside. Okay, like this is capital R, and point P was inside, small r was there, so distance between point and the charge was small r. for everything. And here what did we did, flux phi is equal to Ea, we wrote this, and then E 4 pi r square, okay, small r square. We are finding flux for the point. So then we also know from Gauss theorem phi is equal to q by epsilon naught, but charge which is enclosed by Gaussian surface is 0, okay. The charge here enclosed by Gaussian surface is 0, so phi becomes 0, okay. Then then when q is 0, E also becomes 0, okay. So phi, so E becomes 0, then this is the required answer. We are finding electric field, so E is 0. So we will make a little graph. So I assume that you can see this graph. It is simple graph, you can also understand this. This is on the surface of the plate, outside the sphere region, inside the sphere region. Small r is greater than capital R. Okay, this is simple graph. On the surface of the plate is maximum, and inside the sphere region, this is the inside the sphere region, this is outside the sphere region. Charge, electric field is decreasing. Okay, thanks for today.